All right, I think we're rolling. Well, hello everyone. Welcome to the final installment of the Inline-Four workshop. Sorry for the delay, but in this particular section, what we'll be doing is we'll be creating the casing for the Inline-Four engine. So we'll be creating the cylinders, the accommodation, as well as the gear, and just showing how to do a basic belt mate. So I think we could get right into it. So here, let me share my screen. I always forget to do that. Okay, so I've got my SolidWorks open here, and we're going to create a new file. Alrighty. Now the first key thing is we got to make sure our units match up. So I'm going to switch from MMGS units to IPS units just for consistency. Even though, again, take this with a grain of salt because an actual engine casing won't have these dimensions. But okay. So what I'm going to do is I'm going to create a new sketch on the top plane here, our good old friend. And we're just going to draw a regular rectangle. Nice alliteration. And I'm going to apply a dimension of 10 inches to this side length here. And then on the top, actually, no, we'll wait for that. But essentially, I'm going to use the 3-point arc tool to inscribe a little arc within here. It's perfectly fine to do any arbitrary point. The only thing is you just want to make sure your angle here is 180 degrees as I've got it. So you want it to be coincident with the midpoint of this particular thing. Although later on we're going to be getting rid of this line, so that dimension, that relation will automatically go away. So we'll fix that later on. But essentially, you want the side edges of this arc to be 1.125 inches away from the actual the rectangle that we've created. And then you want the radius to be 4.75 inches. There you go. And then the last step would be just to get rid of this line here. And as you can see, we're underdefined, so we'll fix that very quickly. So we have a length here, and then what we can do is just apply a vertical relation with the midpoint of this top line. So essentially this arc is now stuck in place, it won't move anywhere, and we've fully defined it in all of our dimensions. So from here, I am just gonna extrude this bad boy. So let's say 14 inches should be adequate. 14 inches, so it should look something like this, almost like a little Lego character's hand. And what I'm going to do now is I'm going to use our trusty mirror tool. Now, this could be very useful because essentially what we want to do, so this is one cylinder, we want to propagate this 3 additional times, right? So what we can do is we can select our mirror face to be this edge right here. And then we want to mirror this body. So if we do that, and if we ensure that merge solids is selected, essentially what that'll ensure is that the whole thing is just one homogeneous body and that you don't have 2 distinct bodies. If we press OK, you'll notice there's no line intersecting both of them. So this is just one proper body that we've created. Beautiful. And what we're going to do is we're just going to replicate this. So I'm going to click this mirror face plane right here. And then I'm just going to click this body once more. And as you can see, we have enough space for 4 cylinders. Now, keep in mind for this engine casing, what we're going to do is we're essentially going to have it be like a half of an engine casing, just so you guys can see the actual motion of the piston without having to do an exploded view, or not an exploded view, sorry, a split section view. Now we finished our first part. What we need to do is apply some fillets here. So let me see, our fillets, according to my dimensions, they should be 1 inch. Yeah. Oh, sorry. Don't know why it chose that. Accidentally exited the choice. There we go. And we're going to just click these 2 back corners. All right. If we apply that, this is what you should have so far. So we can already see this starting to take shape. So I'm going to create a new sketch on the bottom of our new body. I'm going to make sure that the camera is properly oriented. And from here, essentially all we have to do is we have to press convert entities. Oh, my apologies. Okay, we'll select all of these different components, just these interior components out here, or these exterior components, and just press OK. And then from there, all we need to do is just offset all of these features or these lines by 0.5 inches from what I presume. Yeah, 0.5 inches. I'm just going to reverse the direction on this bad boy. And then the only thing left to do is to close the contour such that we can extrude this. So we're going to draw a horizontal line from the top of each corner. And as you can see, we have this like dark blue outline within our, or sort of fill within our sketch contour. So this is good to extrude, and it's fully defined. From here, what we're going to do is we're going to flip the direction, and we're going to extrude this by 0.5 inches. So the same as the length of extrusion here. So we'll have like a nice sort of square type of rectangular prism. So we press OK here. Should be good to go, and it's merged our body. Now, essentially, we don't want to keep propagating the same feature over and over again for each of the different levels of this casing. So what we're going to be using is the linear pattern tool. So this will allow you to, as the name insinuates, linearly create duplicates of the feature that you just made. So we're just going to go up the casing. So for our direction, I'm going to have this selected. I'm just going to click this top or this vertical line here. Doesn't matter. It can be any arbitrary line you want. And then let's see. So I am going to put a spacing of, I'm just referring back to my previous notes here, 1 inch, and we want 14 instances. Now what's left is to select our feature. So we're just going to select this new sort of edge that we created, and we're just going to flip the direction. So we just essentially want to create these ribs on the outside of the casing. And there we go. And you see it's all perfectly fit with regard to, so we don't have any additional lines indicating that these are two distinct bodies. Okay. Now what we want to do is we want to create a new sketch. So we want to click on the casing here. So not on these extruded fins, but on the casing itself. And essentially what we want to do is we want to make our camera fit here. All right. And let's see, our origin is oriented correctly. Perfect. And essentially all we want to do is just count between the second and third rib here. So 1, 2, 3, we want to go in between these two. And essentially what we're going to be doing is we're going to create a little shaft on which the gear simulating our drive gear will rest, and it'll be able to rotate around this. So what I'm going to do is I'm just going to create a circle, and we can essentially set the origin to be 3.57 inches away from this. Again, it's really up to your personal preference. This is something we mostly did arbitrarily, such that we can just have like a representation of what we want the actual piston to do, or the actual engine to do. And what I'm going to do is I'm going to just take the distance between this edge and the other edge. So I'm going to measure this. So between one indent and the next indent, what's that distance? So our delta Y should be 0.5 inches. Yeah, that makes sense. So essentially what we want is the middle of our circle here to be 0.25 inches away from one of the sides. So we want it to be right in the halfway point. And as you can see, it's perfectly lined up. We could have also used like a tangency relationship here as well. It doesn't really matter, you're going to get the same result. So I'm just going to extrude this by 3.65 inches. And you'll see it sort of comes out like so. And that's perfectly fine. Again, it doesn't really have any sort of functional use to it. In real life, it wouldn't actually be like this. But again, for the purpose of this tutorial, we're not going to go into the intricacies of the actual connections for the Inline-Four engine. Essentially, the focus is just mostly on the crankshaft and the pistons, which are the most integral components of this whole assembly. All right, so what we've done is we've created our casing. So I'm just going to save this. So let's call this our casing. Beautiful. And I'm just going to create a new folder. So video. Oh, I've already got another one called vids. I know, very profoundly named, but hey, what can we do? It's pretty late. Now I'm going to create a new file. And this is essentially going to be the accommodation for our drive shaft here. So the drive shaft, I mean, not the drive shaft, sorry, the crankshaft. So essentially the crankshaft needs to fit on a circular region so that it can rotate freely, but it doesn't move from a translational aspect. So from like an XYZ aspect. It's all about those support reactions, baby. So what I'm going to do is I'm going to click on this right plane. I'm going to create a new sketch. And essentially what I want to do is I want to create an annulus of sorts. So let's see. What we can do is we can just create one circle. Oh, sorry. Our units. IPS, very important. We'll go back into our sketch here. So IPS units. And essentially I'm going to create two circles. Two circles. And the first one's going to have a diameter of 4. And actually, you know what, let's skip that step because I want to stick consistent to our tutorial document. So what I'm going to do is I'm actually just going to draw a line from the top here. And essentially all we're going to do is we're just going to trim these following entities, right? So essentially in annulus, we want half of it. Realistically, the accommodation would actually be a full circle, but again, just to show the motion of the piston and the crankshaft and everything, we're only doing half of the casing. So what I'm going to do is I'm going to apply a dimension of 2 inches for this inner radius. And for the outer one, I'm going to apply a dimension of 2.75 inches for that radius. Okay. And what we're going to do is we're going to extrude this semi-annulus by 3 inches in the opposite direction. Let me check. No, sorry, this direction. Essentially, you want your semi-annulus to be on the left-hand side. Perfect. Starting to come along. Now, what I'm going to do is I'm going to create a sketch on this back end. So essentially, this is where we started our sketch from for the semi-annulus. And essentially, this step is a little bit more complicated than the others. So I'll go through it a little bit slowly. So what I'm going to do is I'm just going to create a rectangle. And I'm going to give the top a dimension of 9 inches. And then with regard to the actual vertical height, I'm going to click on these 2 points. And I'm going to give it a height of 9.3 inches. And essentially what we can do is we can just mirror this about itself. So I'm going to mirror this inner chain. Oh, whoops. My apologies. I'm going to mirror this inner chain. And we're going to mirror it about this line here. So we have 2 even squares here. All right. And essentially from there, sorry, pardon me. What I'm going to do is I'm just going to create an arbitrary arc here that will essentially connect to this bottom corner, but you know, it doesn't really matter where you select that first vertex that I created here. And essentially what you want, so you're going to click on this arc and you're going to click on this arc, shift click, and you want the 2 to be concentric. Okay. So essentially what they'll do is they'll follow the same arc. It's almost like this arc was an offset that's been cut off, right? They'll follow the same outline. And from there, we can essentially just trim out the bottom here and then trim this part out. And as you can see, we've actually lost a lot of our dimensions. And that's mostly because of the fact that, for instance, the length was a reference dimension for the width, and for the height, we no longer have the bottom edge, and so on and so forth. Furthermore, I'm just going to press the Convert Entities tool, and I'm just going to convert this edge here. And essentially, I'm going to trim this middle portion as well. Okay. And essentially what we can do is set this again to be 9.3 inches, as well as the bottom. We're missing out on that. And as you can see, it's fully defined. And now we have the shape, or the general shape of our casing here. So I am going to extrude this by 1 inch, facing opposite of the semi-annulus. Beautiful. Now I'm going to sketch on this back end here. And essentially what we're going to do is we're just going to replicate everything that we had, but we're going to offset it. So I'm using the Convert Entities tool. So essentially copying everything onto this plane. So essentially these two lines now fall under our current sketch. Okay. And what we're going to do is we're going to use the Offset Entities tool here. So I think we're going to offset this by 1 inch, if my notes treat me correctly. Yeah, that looks about right. And we'll close off this loop with lines, and then we should be good to go. Beautiful. Now, as you can see, we have this sort of empty corner here. I'm not sure if you can see this right now, but essentially what we're going to do is we're going to extrude this new outline all the way across here, and then we're going to mirror it. So I'll show you how to do that. If we press extrude boss/base, essentially we want this to go in two directions, right? So I'm going to reverse the first direction, and we're going to extrude by 1 inch. That's perfectly fine. It's essentially just to accommodate for this corner piece here. But we're going to enable the second direction as well. And for this direction, we're going to extrude by 22.4 inches. Again, this is all according to measurements that we've done before. And if we do that, this is essentially the body that we're going to get. Right? So as you can see, it's half of our casing here, or half of our crankshaft accommodation. So it's really starting to come together. And what we can do, this is the notoriously easy part of it, is we could just mirror this about our new mirroring plane. And we can mirror this entire body, right? And essentially what we'll have is the exact same thing on the other side that's been fully merged. So I had merge solids selected there. And this is our accommodation. Beautiful. We can save this. Accommodation. Alrighty. Now, what's left is we have to make the gear for it now. So essentially we had the gear that, this is essentially going to be where the belt connects to the crankshaft. So the crankshaft will connect to one end of the belt, and then this will connect to the other end of the belt. So this will be the main part that transmits power to our drive or driven shaft. So essentially to our wheels and our gearbox, any type of configuration that we may have. Again, vehicles vary and their transmissions do as well. But let's see. Okay. So for this, we could just select the front plane as our sketch plane. Forgot units, IPS, very important. Let's do that again. And essentially what I'm going to do is I'm going to create a circle. But I'm going to give this bad boy a radius of, a diameter of 6 inches. Okay, diameter of 6 inches. And essentially what we're going to do is we're going to extrude this by 2 inches. So we'll go this way. Nice. All right. I'm also going to set a reference axis here. So I clicked into reference geometry and axis. And essentially what we're trying to do with this, so if I click here, this reference axis essentially has an axial reference point within our cylinder. And essentially what I'm going to do is I'm going to do a revolved cut around this axis. Okay, so if that you'll see what I do quite soon. But essentially what I'm going to do is I'm going to create like an indent within this gear such that the belt can actually fit into it. So there's a little groove for it. So we'll have that axis here, and then we can create a new sketch. So in terms of our plane, we can select the top plane. That would be ideal for this. Okay. Now, essentially, we have to create this little outline here. So what I'm going to do is I'm going to create another center line here. So I'm going to click this. So this is essentially going to be like a form of reference geometry for us. it won't actually contribute to the shape of the object. And essentially, we're going to draw a couple of lines. So a couple of arbitrary lines that look somewhat like this. Okay. So that's one portion of it. And essentially, we can just apply our dimensions here. So this was 0.5 inches. Okay. This dimension, so the horizontal dimension or the vertical dimension, sorry, of this component should be 0.25 as well. And then the vertical component of this should be, let me see, should be 0.5 inches. There we go. It's fully defined. And what we can do is essentially mirror this. So I'm going to mirror these three lines about our center line. So this is what we were going to use this for. I press OK there. Beautiful. And essentially all we have to do now is just close this contour. So I'm just going to create an arbitrary box such that our revolved cut fully engulfs this. So let's just say 0.2 inches. Again, this part doesn't really matter. And let's see. Okay, everything should work now. So essentially now what we're going to do is we're going to click Revolved Cut. All right. And our line of revolution, let's get rid of that. Let's click our axis. And then for our selected contour, we'll select this contour here. And essentially, if we press OK, you'll notice we created this sort of geared component where there's a groove right in the middle of it. And as well, if you remember, I'm not sure if I have, no, I don't have the casing open, but essentially that little circular extrusion or that cylindrical extrusion that we had towards the top of the casing, this is going to rest on that axle there. So essentially what we're going to do is we're going to create another sketch within here, normal to this plane. And if you remember, the diameter of that was 1.5 inches. So we'll put that there. And essentially do an extruded cut and click through all, or 2 inches. Again, doesn't really matter, but through all is probably the best choice here. And this is our, let's call it driven wheel. Beautiful. Okay, now we've pretty much got everything. Yeah, we can create a new assembly. So I'm going to create an assembly from this part. Oh, wait. Did I? Okay, let me double check. Okay, this is an IPS, perfect. Yeah, it changed and it said MMGS for a moment there. And I was like, oh boy, we're gonna have to do this again. But no, we are all good. So we're within our assembly now. Let's just have everything in here. Let's insert our casing. Beautiful. And this driven wheel should not be fixed. So we'll make that a float and then essentially make this component fixed, so our casing. Now I'm just going to do a regular concentric mate about this little axle here. And with regard to the actual position of this, let's just say this face is going to be coincident with that face. So this may not be the actual true way it fits. Again, we'll fix that quite soon. Next, let's see. We want this casing to be flipped around and symmetric with the casing on top here. So essentially what we're going to do is we're going to go into our advanced mates, click width. And for our width selections, we can essentially select this bottom side here and this bottom side here. Again, it doesn't really matter as long as if they're the same mirrored distance. Okay. And we're just going to take this mirrored tab and this mirrored tab to go. And we're going to change the mate alignment such that it looks like this. Perfect. And then as well, what we're going to do is we're just going to apply a coincident mate between these two, which here, I got to fix the orientation of this guy a little bit. One moment. Sorry about that. Beautiful. Okay. Yeah, because sometimes SolidWorks rejects items that aren't necessarily close to one another for coincident mates. But yeah, it should be better now. Okay. And then what's left is to just sort of attach this to this component here. And as you can see, it's a perfect fit. Nice. Now, what's left is just to insert our previous components. So if I go back into my workshop, we can put in our crankshaft. Now, the one thing I will admit is that the crankshaft actually doesn't go the entire way here. So that was more or less an error from a previous video, but the solution is very simple. Essentially, you could just extrude this. In fact, I'm going to do that right now just for ease of mind. So let's just create a new extrusion on this crankshaft and say it is, so we're going to convert entities, put a new circle here, and essentially extrude this by, for a comfortable margin, let's say 2 inches. No, let's do 3 inches. Yeah, that should be better. Okay. Yeah, that looks a lot better in my opinion. Let's be more safe here. Sorry, let's do 5 inches. Yeah. Okay, perfect. This is much better. Okay. Now, if we go within our assembly, you'll see everything's been updated. So we can just apply some concentric mates here. And essentially all we want is for this to be shifted down like so. Beautiful. Now, what's next? We want to put in our pistons. So we go and insert our piston assembly that we created before. So I've labeled it aptly piston assembly. It may take a little while to load because it's some more complex geometry, but essentially if we bring this closer here, there we go. Yeah, SolidWorks can be very deceptive in terms of like the space in which all of this fits, but essentially we're going to apply a concentric mate between this part of the crankshaft and the actual piston itself, such that it fits like so. And then essentially you want a coincident mate between the inner edge of this with the outer edge of this piston, such that it's centered perfectly. And then furthermore, you'll notice we can still move this crankshaft like so. To fix this, essentially what I'm going to do is I'm going to create a concentric mate with the piston head and the cylinder itself. So if we click here and click here and change the rotation, you'll notice we have a fully concentric mate. And then it's fully defined for some reason. My SolidWorks tends to glitch out in that regard, but you'll notice this is all perfectly lined up. So that is awesome. Okay. And then furthermore, we can just press Control. Oh, whoops. That brought in the piston head. That is not what I wanted to do. My apologies. So I want to bring in the full piston assembly. So I'll just Control Shift that, Control Shift once more, and then Control Shift once more. Whoa, 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 that created way too many. My apologies. It's because I had multiple selected. But let's see, we have 4 pistons. That's perfect. Our car only has 4 pistons. Now we're just going to repeat the same process. So if you want to skip ahead for this part of the video, be my guest. That is totally fine. And I will not hold it against you. Not like I ever would. Okay. And this guy is going to mate like so. Alrighty. Oh, I may have not selected the right one. Which one did I do that mate for? My apologies. I should definitely be a lot more organized in the way I do these mates. But unfortunately, beggars can't be choosers sometimes. Okay. And then finally, we just want to establish a concentric mate between these two. some reason it's not cooperating. Oh, it's because this thing is fully defined. Yeah, I'm not sure why it's doing this, but let's see. If we can get rid of one of these mates, perhaps it will help us out. Let's see. Is it fully defined? Yes, it still seems to be. See, this is, yeah, a very peculiar part of my SolidWorks where for some reason it just completely fully defines my objects, even though the mating should be sufficient to allow it to move. Okay, I think the best way to approach this here is perhaps to suppress some mates, and yeah, we'll suppress this one for now. And there we go, the piston is free to move. We can try applying our other mates first. Okay, it's one mate. See, it just fully defines it with that concentric mate. It's absolutely peculiar. Should be able to move freely. Okay. And yeah, essentially you just want to repeat this entire process multiple times. It's a bit frustrating, but what can you do? But as you can see, our piston is, or our inline-four engine is starting to come to fruition. So if we select this final face, okay, and then this guy is going to be aligned like so. Yep. As you can see, we should be all good to go. Then we'll just apply this final concentric mate. Beautiful. And there we go. Here is our piston, or I mean, sorry, our inline-four engine. Now, the one thing I do notice is this axle seems to be far too short. So what we can do is we can actually make that a little larger. So let's go back into our casing here, and let's make that approximately 5 inches. Should be more than enough. Okay. If we go back into our assembly here, essentially, there we go. We have these two sort of semi-aligned with one another. Let's add 0.5 inches onto that, just for good measure. So let's say 5.5 inches. Brilliant. Okay. And then the final step would just be to add the gear and belt mate. So I'm not going to go into the intricacies of this because I'd like you to actually play around with it a bit and see how it works for yourself. But essentially, I'll show you how to get started. And this will help you with your future motion studies. So essentially, if you go into Assembly Features here and press Belt/Chain, essentially what you can do is you can click two members. Now, the reason why, if you remember, I created this groove for this particular component here is because we want our belt to actually fit on there. So outside of class, I actually work on the Baja team's CVT transmission, and this is sort of the same principle, where you have a belt dictating the power output and transmission. If you click those two and press OK, essentially you'll have the outline of a belt. And from there, you can essentially have sort of a gear mate to allow it to move proportionately. Again, that's something I'd recommend playing around with. But I think this, for the most part, concludes our inline-four assembly. Now, we did this fairly quickly, so there may be a few small interferences here and there, but I hope you generally got the gist of the tools to use to actually make this engine. And, you know, we thank all of you guys who attended throughout all of the lessons, or perhaps even watched the recordings after the fact. It really does help us out. So if you have any questions, you know, feel free to email me or contact any of our executives, and, you know, I'm happy to help. So thank you very much. This is Nima from McGill Academy, and I hope you have a great day. All right, so let's end this recording.